Role of universal set in context. So let's move on to a really important idea about universal sets. Now, in the sections we've covered so far, we've learned what a universal set is. It's the set containing all the elements we're interested in for a particular discussion. And we've also looked at how to write it down using set notation. But here's a crucial point. The universal set isn't something that's set in stone. It's not a one-size-fits-all kind of thing. Instead, it actually changes depending on the specific problem we're trying to solve. Think of it like this. If we're talking about fruits, our universal set will be different than if we're talking about numbers or students in a class. This idea that the universal set depends on the context is really important. Understanding this flexibility is absolutely key to being able to correctly apply set theory to solve problems. If you get the universal set wrong, it can throw off everything else. So, over the next few slides, we're going to explore this context dependence with lots of examples to make sure you really grasp this concept. We'll look at how to choose the right universal set for different scenarios, and what happens if you don't. Understanding context dependence. So let's move on to understanding a really important idea about the universal set. As we discussed on the previous slide, we have a universal set, and we use the capital letter U to represent it. Now, this U, the universal set, includes all the elements we are thinking about for a particular problem or discussion. Think of it like this. It's a boundary we're setting around everything relevant to what we're currently working on. And crucially, what falls inside that boundary, what makes up the universal set, isn't fixed. It changes. This means that what constitutes the universal set depends entirely on what we are talking about. If we switch the topic, the universal set switches too. We saw in the introduction that it's not a one-size-fits-all thing. There isn't just one single universal set that applies to every single math problem ever. That would be nice, but it doesn't work that way. Instead, the universal set is defined by the scope or the boundaries of the specific problem we're trying to solve. We'll see this clearly in the examples coming up, where you'll notice how the universal set changes dramatically depending on whether we're talking about fruits, numbers, or students. So, always remember to think about the context before defining your universal set. Examples. So we've talked about what a universal set is. It's the set containing all the elements we're interested in for a particular discussion. And importantly, we established that this isn't a one-size-fits-all thing. It changes depending on the problem. Now, this slide says, let's illustrate this with several examples. What we're going to do now is look at a few different scenarios. By working through these, you'll really get a feel for how to identify what should be included in your universal set. We'll see how the universal set changes drastically depending on what we're talking about, whether it's fruits, numbers, students, or even just letters in a word. We'll start with a simple example and then gradually build up your understanding. Don't worry if it seems a little abstract at first. The key is to practice identifying the scope of the problem and then listing all the relevant elements. We'll then move on to a step-by-step guide on how to choose the universal set and also discuss common mistakes to avoid. So, let's dive into the first example and see how this works in practice. Example 1, fruits. Let's move on to our first example to really solidify this idea of a context-dependent universal set. As you can see on the slide, we're going to suppose we are discussing fruits. Now, remember from the previous slides, the universal set contains all the elements we're considering for a particular problem. So, in this context, what could our universal set, which we denote by capital U, look like? Well, we might define it as the set containing apple, banana, orange, grape, strawberry, and mango. Notice I'm simply listing these fruits within curly braces. That's how we represent a set. So we can read this as U equals the set containing apple, banana, orange, grape, strawberry, and mango. Here, we've specifically defined our universal set as the set of these common fruits. It's important to understand that this isn't a definitive list of all fruits in the world. It's just the fruits we're choosing to consider for this particular discussion. And this is key. Any set we define within this discussion, for example, let's say we wanted to look at the set of red fruits. That set would automatically be a subset of U, meaning all the elements in the set of red fruits would also be found within our universal set of fruits. We'll see more examples of this as we go, but this illustrates how the universal set acts as the overarching container for everything we're analyzing in a given problem. Remember, we'll be looking at different contexts in the following slides, and the universal set will change accordingly. Example 2, even numbers. Let's move on to our next example. As we discussed in the previous slides, the universal set really depends on what we're talking about. So, now let's consider a problem involving numbers. Specifically, imagine we are working with a problem that focuses on even numbers between 1 and 10. In this scenario, what would be our universal set? Well, it would include all the possible even numbers within that range. Therefore, we can define our universal set, which we denote by capital U, as the set containing 2, 4, 6, 8, and 10. So U equals the set with elements 2, 4, 6, 8, and 10. Now, it's really important to notice something here. This universal set is completely different from the one we used when we were talking about fruits, remember? We had apple, banana, orange, and so on. This new universal set only contains numbers, and specifically, even numbers between 1 and 10. This highlights the key point we've been building towards. The universal set isn't some fixed thing. It's specific to the problem we're trying to solve. As we move forward, remember to always identify the context first before defining your universal set. This will be crucial when we start applying set operations, as we'll see in the following slides. Example 3, students in a class. Let's move on to another example. This one shifts gears a bit from fruits and numbers to something more relatable, students. So, imagine we are talking about students in a math class. Now, remember from the previous slides, the universal set, denoted by U, is everything we're considering within this particular problem. In this scenario, the universal set might be represented as U equals the set containing Alice, Bob, Charlie, David, Emily, and Frank. Essentially, this U represents all the students who are currently enrolled in the class. It's a list of all possible members we might be discussing if we were, for example, looking at who passed a test or who is in the chess club. Just like with the fruits and the numbers, this universal set is specific to this problem about the math class. If we started talking about students in the English class, our universal set would change. It would include those students instead. We'll be looking at how to choose the right universal set in the next slide, and why getting it right is so important for solving problems accurately. Remember, it's all about defining the scope of our discussion. Example 4, letters in a word. Let's move on to another example. This one is quite straightforward. As you've seen in the previous examples, with fruits, even numbers, and students, the universal set really depends on what we're talking about. Now, let's say we're focusing on the letters within a specific word. So we define our universal set, denoted by capital U, as the set consisting of M, A, T, and H. I'll say that out loud for you. U equals the set containing M, A, T, H. Notice that this universal set is very limited. It only includes the letters that appear in the word math. If we were analyzing a different word or a sentence, our universal set would change accordingly. This example really highlights the point we've been making. The universal set isn't some fixed, predefined thing. It's a tool we define based on the specific problem we're trying to solve. Now, in the next slide, we'll formalize a step-by-step process for choosing the correct universal set, so you can confidently tackle any problem involving sets. Step-by-step breakdown of choosing a universal set. So now that we've seen several examples of how the universal set changes depending on the situation, let's break down how to actually choose the universal set for any given problem. This slide outlines a step-by-step approach, and it's really important you master this. Step 2, list all relevant elements. Once you understand the problem, start brainstorming. What are all the possible elements that could be involved in solving this problem? Think broadly at first. Write down everything that seems potentially relevant. For example, if the problem is about shapes, list all the shapes that might come into play: circles, squares, triangles, and so on. Don't worry about being perfect at this stage, just get everything down on paper. Step 3. Define the universal set. Now, take that list of relevant elements and create your universal set, which we denote as U. Remember, the universal set is a set containing all of those elements you just identified. So, you're essentially grouping everything together that's potentially part of the discussion. This is where you formally write it out using set notation, curly braces enclosing all the elements. Step 4. Ensure completeness. This is a crucial final check. Once you've defined your universal set, step back and ask yourself, does this set include everything I need to solve the problem? Are there any elements that you might have missed? If so, add them to the universal set. It's better to be slightly inclusive than to leave out something important, as that could lead to an incorrect solution. Remember, everything outside of your universal set is considered irrelevant to the problem, so you want to make sure nothing relevant is excluded. Step 1. Identify the problem. The very first thing you need to do is carefully read the problem statement. I mean really read it. Understand exactly what the question is asking and what topic it's about. What is the problem discussing? This seems obvious, but it's where many students make mistakes. You need to grasp the core subject matter before you can define the scope of your universal set. We'll then look at why getting this right is so important, and some common mistakes to avoid. But mastering these 4 steps will give you a solid foundation for correctly defining the universal set in any set theory problem. Importance of correctly defining the universal set. Let's move on to slide 9. This slide highlights why getting the universal set right is so important. It's not just a formality, it directly impacts your ability to solve problems correctly. The slide starts by stating that defining the universal set correctly is crucial, and then it gives us 3 key reasons why. First, it says that the universal set defines the boundaries of your discussion. Think of it like drawing a fence around everything you're interested in. Anything outside that fence, anything not included in your universal set, is considered irrelevant to the problem. We're essentially saying, we're only concerned with the elements within this set, everything else we're ignoring for the purpose of this specific question. Remember how we talked about the context changing the universal set? This is where that really matters. If you don't define those boundaries clearly, you might accidentally include things you shouldn't or miss things you need. Secondly, it explains that the universal set affects the interpretation of set operations. Now, you've already learned about operations like the complement of a set. Remember, the complement consists of all the elements that are in the universal set but not in the set you're looking at. Well, that definition is entirely relative to the universal set you've chosen. If you change the universal set, you change the complement. So, if you get the universal set wrong, your complement will be wrong, and any calculations involving it will also be wrong. Finally, and perhaps most importantly, the slide emphasizes that correctly defining the universal set ensures accurate problem solving. Simply put, an incorrectly defined universal set can lead to incorrect conclusions. It's like building a house on a shaky foundation. If the base is wrong, everything else will be off. We've seen in the previous examples how different problems require different universal sets. If you don't carefully consider the context and choose the appropriate universal set, you're likely to end up with a wrong answer. So, before you even start solving a set theory problem, take a moment to clearly define your universal set. It's a small step that can save you a lot of trouble down the road. In the next slide, we'll look at some common mistakes people make when defining the universal set, so you can avoid them. Common mistakes. First, a very common error is defining the universal set too narrowly. What does that mean? Well, remember from the previous examples, the fruits, the numbers, the students, that the universal set needs to contain everything relevant to the problem. If you accidentally leave out an element that could be part of the discussion, your analysis will be incomplete. For instance, if we were talking about fruits and only included apple, banana, and orange, but forgot about strawberry, any question about strawberries couldn't be answered within our framework. Next, we have the opposite problem, defining the universal set too broadly. This happens when you include elements that aren't actually relevant to the problem at hand. While it might seem safer to include everything, just in case, it actually makes things more complicated. Think about it, the more elements you have in your universal set, the more you have to consider when performing set operations, and it increases the chance of getting confused. It's like adding extra, unnecessary information to a problem. Finally, and this is a big one, is assuming a universal set is fixed. We've emphasized throughout this tutorial that the universal set is not a universal constant. It doesn't stay the same for every single math problem. Remember, it always depends on the context of the specific problem you're trying to solve. If you fall into the trap of thinking there's one correct, universal set for all situations, you'll likely make mistakes. We saw how different the universal set was when we talked about fruits versus even numbers. It all depends on what the problem is about. Let's move on to slide 10, where we discuss some common mistakes students make when working with universal sets. It's important to be aware of these so you can avoid them in your problem solving. So, keep these 3 mistakes in mind as you practice. By avoiding them, you'll be well on your way to correctly defining universal sets and solving set theory problems accurately. Now, let's move on to the final slide where we'll recap the key takeaways. Key takeaways. Let's recap everything we've learned about the universal set with these key takeaways. Pause first, and this is really important. The universal set is not a universal constant. What I mean by that is, it's not something that's fixed for all time or for all math problems. It is instead context-dependent. Remember how we looked at fruits, then even numbers, then students in a class, and even letters in a word? Each time, the set of all possible elements changed, didn't it? That's because the context, what we were talking about, changed. Secondly, the choice of what to include in the universal set is determined by the scope of the problem being addressed. Scope just means what the problem is asking you to focus on. If a problem is about identifying prime numbers, your universal set might be all whole numbers. But if it's about prime numbers less than 20, your universal set becomes much smaller, just the numbers from 1 to 19. It's all about what the problem is asking you to consider. Now, why does all this matter? Well, correctly defining the universal set is essential for accurate set theory applications and problem solving. Think about it. If you get the universal set wrong, operations like finding the complement of a set, that is, finding all the elements not in a particular set, will be completely off. It's like building a house on a faulty foundation. Everything else will be unstable. Finally, and this is a good rule of thumb, always carefully consider the context to determine the appropriate elements to include in the universal set. Before you even start solving a problem, take a moment to ask yourself, what exactly is this problem about? What are all the possible things I might need to consider? That will guide you in creating a universal set that's just right, not too big, not too small, but perfectly suited to the task at hand. So that's it. We've covered the core idea of the universal set and how it adapts to different situations. Make sure you practice identifying the context and defining the universal set in various problems. This skill will be incredibly valuable as you continue your study of set theory and beyond.